So we're going to continue our topic on data manipulation. So far we've covered basic variables, arrays, two-dimensional arrays, and now we're going to talk about a new, really kind of handy one called an array list. Most languages have some variation on this, but in Java it's called an array list. And what an array list is, basically it's an array that grows and shrinks as needed. So you don't you can specify a size of 0 to start, or you can specify a size of 20 or whatever you want if you really wanted to do things like that. But you don't have to. And what you need to realize is that it will actually get bigger as you add in more elements and shrink down as you remove elements. And what this allows you to do is never have to worry about gaps. You never have to worry about the extra space at the end. And even when you remove elements in the middle, it kind of squeezes everything together. But with that, you have to realize is that you can't always expect the same element to be in the same location. So at one point, one element might be at index 5, but you delete index 3. So now that one that was at 5 is now at 4, because it gets shifted up. So an array list is a very powerful tool. And as I said before, we do have the ability to grow and shrink. So let's say we have a simple array right here, which has the values, let's say 3, 9, 7, -2, and 4. And they're at elements 0, 1, 2, 3, and 4. And we just decide to delete this guy. What happens is this one gets shifted up and this one gets shifted up. So it ends up going to another grid, but this time a lot smaller. So we have 3, 9, -2, and 4. Sorry, this shouldn't be here at all. And then we have 0, 1, 2, and 3. So our physical size of our array list has changed. Now an array list is a special thing. It is an object. It's not like an array. It does have properties. It does have data all about it. And we need to use things like that. So it doesn't have some things that we would expect in a regular array, but it has a lot more functionality as a consequence. Now you might think to yourself, wow, an array that can change sizes, grow and shrink, it can do all these fancy things, I can add, I can insert, I can remove. Why would I ever use an array? Well, the basic truth is that sometimes an array list is overkill. It has extra overhead and it takes up extra space to maintain that array and use that functionality. Whereas an array is a bare bones, whereas an array is a bare bones piece of data. There's no bells, no whistles, it is what it is. So there's no wasted space, there's no wasted memory, there's no wasted CPU time. Everything is done and done as efficiently as you decide to make it. So that's the key. If you can make it an array and make it efficient, you should use an array because it will save you space. However, if space is not a concern for you, or sometimes speed, then an array list may be the better course of action. So how do we actually use this and what can we do with it? Let's go into our program and find out. So in Java here, first thing you need to realize is that in order to use an array list, you have to import the following library. Import java.util.ArrayList. Now in order to create an array list, it is an object, and it's a special kind of object called a template object. And basically you have to specify what type of data you want it to work with. Kind of like when we create an array, we specify we want it to be an array of integers or an array of strings or whatever. We have to do the same thing with this, but in a different way. So first thing I need to say, hey, I'm creating an array list object. For now, what I'm going to do is I'm just going to create an array list of like top scores or something like that. So array list top, these are going to be integers. So I put them in those angled brackets to specify the type. That's what the template does. Got to give it a name. Let's call this scores. And it's an object, so we have to say equals new, and then array list again. And again, I have to specify its type. It's going to be an int. Now at the very end, in round brackets, I can specify its starting size. I'm just going to start it at 0 for now. Oops. I should mention though, it doesn't use the primitive versions of the variables. It uses the object version, so you have to write in integer. And integer over here as well. I apologize. So now we have our array list, and we can start playing with it. So I can add new elements. So I could say scores dot add. Now see all these different versions of add. There's a couple of them. There's one where we just add in a value and it'll throw it at the end of the list. So if there's 5 elements, it'll throw it down as the 6th element. If I use the other version, add index with the element, I can actually specify which index I want it to go at. If I want it to go at the front of the list, I could say put it at index 0, and then everything else gets shifted down. If I want to put it at index 3, it'll go there, and then everything else will get shifted down. But what you do have to realize is that whatever index you're trying to specify, must actually exist. So if there's only one element there, and you want to insert it at index 10, you can't. You're going to get an error. It's not going to work. Well, it'll return a true or false. Actually, no, that will actually break. Anyways, let's add in a value, I don't know, 1,000 points. And just for simplicity's sake, let's display our array list so far. System.out. Oops. We'll do a for loop that goes through each element. For int I is equal to 0 such that I is less than scores. There's no length anymore. Now we have to say dot size. I plus plus. But other than that, it's going to work basically the same way as an array does. So we can actually access the elements using square brackets and whatnot, which is very handy. So I could say system.out.print. Oh, sorry, I apologize. You can't use the square brackets. You have to use the get function. Print ln, and we're going to say scores dot get, and then which index we want index I, and that will display the value. Now if I want to make it a little bit more friendly, I could say no, we'll just keep it like that for now. We run our program and we see the 1,000 show up there. Let's add a few more scores. Just copy and paste this. So we're going to add in 5 scores. Let's say 300, negative 10. Oops. Negative 10, 750, and 1,001. We run this again, and we get exactly the numbers we expected. All we have to do is add. And it always goes to the exact size. Now what if I wanted to remove an element? So what I'm going to do now, I'm going to say scores.remove. Now I need to specify an index. So let's say I want to remove the last element. However many elements there are, well, let's just remove the index 3 for now. If we do this, and we run it, we see that index 3, which is the 750, 0, 1, 2, 3, is now gone. And the 1,001 got pushed up a slot. Now if I wanted to remove just the last element, whatever that last element is, no matter how many that I've added so far, I could actually go like this. I could say scores.size minus 1. And that will give me the last valid element, and you can see the 1,001 is gone. Now what if we did that a few times? We do that 4 times, we still have the 1,000. What if we did it one more time? We have nothing, because there's no elements. So when this array went, it didn't actually go into this loop, because scores.size would give us 0. 0 is not less than 0. What if we did it one more time, though? We get an error. We're trying to remove a value that doesn't exist. So we have to be careful about that. We got to make sure that it's not actually there, or that there is data there. So there is some other functionalities with ArrayLists we can do. We can check to see whether a value exists within. So we could say if scores.contains, specify a number, let's say, or a value, let's say 301. If that is true, then let's just system.out print ln value found. Else, oops, value not found. Control our program. Value not found because 301 doesn't exist. If we change this to a 300, run it, we get value found. So contains will return a true or a false. There's also another handy functionality called clear. So if I go like this, right here I say scores.clear, and then I try and redisplay it again. We only get it once. We don't actually get it twice. It's because it's been cleared out. Are there any other ones that are pretty useful? There is another one called isEmpty. So you could do a quick check around your scores.remove to check to see if isEmpty is false, then you can remove it.